How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a steering cylinder off a 10-ton forklift that's come in to be repaired. So the forklift is actually owned by a good friend of mine. About 6 months ago is when the problems all started. They went to use it and they weren't able to use the steering and it wasn't able to lift. So they had a forklift mechanic go in there to try and diagnose the problem. They did find out that the hydraulic pump was actually destroyed and it wasn't pumping oil anymore. So they did end up replacing the pump with an aftermarket generic unit just to try and get it going. But that didn't solve the problem. So what they tried to do then was put in extra valving and run extra hoses to steal hydraulic pressure from other circuits to try and make this circuit work correctly. But that didn't work. All that did was make the forklift very sluggish and it wouldn't lift anyway. So that forklift has been sitting there for 6 months, not being used, not able to be sent out on hire, while our customer waited for genuine parts to come in from overseas. The parts finally arrived yesterday and my mate gave me a call to get me to go over there and try and sort all this out. So what I ended up doing was removing everything the other guy had already done, and I started to refit the new parts. So I replaced the pump and the new orbital valve. I did have to get a few new hoses made up because the other guy didn't leave the original ones there, and then we started to do the testing and diagnose what the problems actually were. So what I had found is the mechanic had wound up all of the relief valves in order to achieve hydraulic pressure to this particular circuit, so we had to go back and reset all of those, but we still didn't have steering, so we had to investigate a little bit further. So it did work out that the hydraulic pressure was correct, but it still wasn't steering. So I did investigate that further and we did determine that it was the steer cylinder bypassing internally. Over time, seals will start to wear out and sooner or later the oil will just tear them apart and bypass them. It is a very common problem for cylinders that are a very high cycle part, but because of the design of the cylinder, it doesn't show any leaks externally. We're hoping it was just a coincidence that the steering cylinder failed at the same time the pump did, but I do have my suspicions that when the pump failed, it put metal through the system and that could have damaged these seals, causing this problem. So what we're going to do is get this set up in the press and get it disassembled. So that's this gland off. There is no metal particle trapped in there. So now we're going to remove the rod.
What the hell? Oh.
Righto guys, so this has turned into much more than just a reseal. We have had the piston pick up in the barrel, so there is quite a bit of damage on the piston, and the barrel is scored from one end to the other. So this definitely could have been from a piece of metal from the damaged pump, but this is a really bad design. When you do have a steel piston working inside a steel barrel with no protection barrier around it like a wear band or silicon bronze layer, the second these things touch each other, they pick up and they start to make metal. So I'm going to put this down to a really bad design. And it might have been when the steering cylinder failed, it sent metal to the pump and damaged that. So now I'm going to make the call to my mate to tell him what I've discovered. Then he can make the call to the parts supplier to see if we can get a replacement component. But what I'm going to do is start looking for material in case we need to remake it.
Hey,
Mate, your cylinder is absolutely right. I'll start chasing up material, see if we've got stuff available, and I'll wait for your call.
okie dokie.
Thanks, mate.
Thank you, Pat.
Right. So now while we wait for the call back, I am going to turn the barrel around and remove the other gland.
Oh. Looks okay.
That's fine. So I have heard back from my mate. He did do some hunting around to try and find a replacement cylinder. There are none here in Australia. He did find one in America. They're only $320 US, but it is going to take weeks and weeks to get it here. So we're going to rebuild this one. Now I know that we're remaking this, I'm going to get all the seals off the glands. Even though these seals aren't damaged, because we're going to the effort of rebuilding this, I'm not going to use old seals because it could lead to a failure later on. So we're just going to replace them. So there is a soft metal bearing in there with a Teflon coating on it to stop the rod contacting the gland. I'm not going to pull them out because they are difficult to get a hold of, and there's actually nothing wrong with these ones.
Oh, there's an O-ring.
Now we've got those off, we can organise new seals, but the next thing I'm going to do is get the barrel set up in the lathe so we can machine off the mounts.
Oh.
So that's the mounts removed off the barrel. The next thing I'm going to do is machine down the damaged piston area on the rod, but I don't want to damage the chrome work, so I'm going to fit my brass pads to my jaws. So I want to make sure I'm going to have a thick enough layer of silicon bronze after I machine this. So I'm going to take off 1 mil and see if that cleans up. So that didn't quite clean up, so I'm going to take another 1/2 mil. So I've got that to clean up now. That was a total of 1.5 mil off the OD, which will give us a silicon bronze layer of 0.75 of a mil thick, which is going to be perfect. So now we're going to get this out of the lathe, take it to the welding area, and weld on that layer of silicon bronze. I'm going to set this up on my V-blocks and not my rollers because silicon bronze can be temperamental and not give a consistent weld, so I'm just going to weld it and rotate it by hand. And the silicon bronze does make quite a mess. It is very splattery, so I am going to cover up the chrome so I don't damage it. What I'm using is aluminium flashing that I get from a local hardware store. It's 0.7 of a mil thick. It is also reusable, so it's a very cost-effective way to protect the chrome. And to cover the remaining area of the chrome, I'm just going to be using wet rags because this stuff goes everywhere. So the silicon bronze wire we're using is 0.8 of a mil thick, and I'm going to be backing that up with 100% argon. This welder has a built-in silicon bronze setting, so all I do is give it the parameters, the wire size and the thickness I want, and that gives me the volts and wire speed that I need. When welding with silicon bronze, when you come to the end of the weld, it does tend to flatten out. So to ensure I have enough material on there to machine off, I'm going to do 2 layers. Now that's welded, we're going to give that some time to cool down and then we can machine it back to size.
What you got? What's in there? Look, in there. Hey, come on, this way. Go. What you got? Chicken. Where is he? Where is he? Homeless, where is he? What's that? Yeah, bring it in. Oi, come here, come here. You gonna drop it? Drop it? No? Okay.
I'm just going to machine it so it cleans up, and then we can take our first measurement. Our finished dimension we're aiming for is 114.5 mil, and we've still got about 5 mil to remove. Now we're getting close to final diameter. I'm going to use my micrometer to check the measurement, and then we'll take our finished cut. So that's measuring spot on at 114.5. Now what we need to do is crew up all the edges. Now all I need to do is change my tool out to an S&MG neutral so I can chamfer the outer edges. Righto guys, so that's the repair completed on the rod, and this is as far as we can go for now until our new barrel material and our seals get here. So stay tuned for part 2. Thanks for watching.
Is that big enough? That seems really small.
You'd be amazed like little small too. King Dick. So then what they... That's this gland. Oh, fuck. He has done a... because... I fucking didn't like that. Let me go back. Fucking moved it. So this piston is only 0.3 of a mil smaller than the inside diameter of the barrel.
He's talking to his friends in the trees over there. Hey, Russell.
Oh my god, throw at you.
Shoo. That's what you have to do.
Right up, mate.